When we build Power Apps, it's easy to focus on screens, controls, and formulas. But as your app grows, that approach can start to break down. The logic spreads across screens, and small changes can start to have ripple effects everywhere. This happens because, by default, Power Apps doesn't guide you towards a design structure. But developers have faced this problem for decades, and one of the ways they've solved it is by using a design pattern called the Model View Controller, or MVC for short. So today we're going to think like developers and apply the MVC design pattern inside of Power Apps. Channel members have access to download the apps used in the videos, as well as the YAML code used in the components that I showcase. You can click the join button below the video if you're interested in supporting the channel. Now you might ask yourself why we would steal some concepts from traditional software development. And the reality is that Power Apps has a very visual structure that typically draws people into providing all the data, the logic, and the layout all in a single place. And what this does is intertwines the responsibility of those three things, which can wreak havoc when you have to make changes down the road. It's totally fine to build apps this way, but as your app grows, that everything in one place model becomes very hard to maintain. You might change one button, one formula, and suddenly other screens stop working that were dependent on that code. There's no clear separation between what the app knows, what it shows, and what it does. That brings us to this concept of Model View Controller. In traditional software development, this pattern, the MVC, is a way to organize code so that your data, your presentation, and your behavior each have their own layer. The model is your data and your business logic, which deals with how the information is stored, how it's updated, and how it's validated. The view is the user interface, or what the user actually sees. And the controller is typically the middle layer. It listens for the user's actions and tells the model or the view what to do next. In the traditional sense of this pattern, a user would interact with a web page, which the controller then reacts to. It might update the model, and the resulting view would refresh. This separation makes software much easier to scale, and even though Power Apps doesn't officially support an MVC framework, we can absolutely think this way and even build in this way. We don't have the exact structures that we do in traditional software development, but we do have all the ingredients for MVC. The model becomes your data sources and your collections. This represents everything that your app knows about. The view is your screens and controls, the galleries, the buttons, the labels that the user interacts with. Any components that you have that are dedicated to the UI would also be included here. Now that leaves the controller, and this is where things get interesting. The way I generally think about my formulas in apps is that the controller lives inside of named formulas and user-defined functions. These let you centralize your logic and make it reusable. And in a way, it completely separates your logic from the UI. Each layer has one responsibility. The view shows data, the controller decides what happens, and the model manages the data itself. The controller acts as the intermediary between the view and the model, and that ensures that there's a separation of concern. Let's build a very rudimentary example of this in an app. Before we start, you'll need to make sure that you enable the new analysis engine and user-defined functions setting inside of your Power Apps settings. This is very important in making this concept work. We'll start with a very simple example before moving on to something more complex. On a blank screen, we'll insert a button control, and we'll add something like a set function, followed by a notify function. On our screen, or the view in our MVC pattern, we've now tied logic to a button. Maybe we have multiple screens where we're executing this same refresh plus notify behavior, and instead of this being referenced on the button, we can take this formula and go over to App Formulas. This is where we can insert our user-defined function acting as our controller in our MVC pattern. We'll call this FN example action. And the output of this user-defined function is just going to be voided, as we're not returning anything to the controls on our screen. We'll paste in the formula that we had in our button inside some curly brackets, and then we'll end our formula with a semicolon. This is the basic structure of a user-defined formula, and now instead of referencing each of these formulas in our button, we can reference our user-defined function. We can insert a completely different screen, insert a new button on this screen, and call that same user-defined function here. So whether we're on this screen or screen 1, we're able to call that one function from anywhere in our app. Now the beauty of this comes from when we need to update this formula. Maybe we're making a small change to say that instead of adding 1, this adds 2. We don't have to change our buttons at all because they're referencing that one user-defined function. And now both are updated to the new function. Let's look at another example where we have a set of input controls that we're displaying as a form and using a patch function to patch back to our data source. In this case, we might have a submit button as well as a cancel button and then a dismiss button up in the top right corner. In the submit buttons code, we have a patch function patching all the fields from our controls back to our data source and then resetting each control. In our cancel button, we might just have the controls being reset. And you can see that same formula in our dismiss button. Here you can see a lot of duplicated code between all of our buttons, where our save button is unique in that it's patching some information back, but it's got the same reset functions and the same set functions as our two cancel buttons. This is a perfect use case for us to separate the concern of our user interface from the actions that are being taken. Let's just handle our patch function first. We'll copy our patch function and we'll go over to app formulas. Here we'll create a function called fn save case. We won't put any inputs to this function just yet, and we'll have the return type be void. We'll enter an equal symbol and then a curly bracket, and we'll paste in our patch formula. We'll close our curly bracket and then end our formula with a semicolon. With this, we've moved our patch function out of our save button. And if we go back to our save button, we can instead remove this patch function and simply reference fn save case. If we try to make a change, our patch goes through perfectly. Now, how can we decentralize this even more? Our formula is currently referencing individual controls on the screen, which might be different depending on if you're using the same form in multiple places, or even better, using a component for your form. This is where input parameters of the user-defined function come into use. Here we can define input parameters such as ID being a number, description being text, status being text, close date being a date, and comments being text. Whenever our user-defined function is referenced in our app, we'll be required to put in these parameters, and we can use those parameters in our formula. So in this case, instead of tying our patch function values to controls on the screen or variables, we can instead tie them to our input parameters. I preface these parameters with SCP to denote that these are only used in the scope of this formula, very similar to a with function where those are only used in the scope of that specific formula. So now our save case function is requesting this information whenever it's called by a control on the screen. So if we go back to our save button, you can see now it's giving us an error and telling us that it's expecting 5 arguments. So we can input our ID, our description, our case status, our close date, and our comments. Now this may seem like a lot of work up front, but what you're doing is you're standardizing exactly what is going into your controller and exactly what is being sent back to your data source. So let's try this out. And you can see our data is updated. Now again, especially in the context of components where you might be reusing this same overlay multiple places in your app, you're standardizing the code that all of those components could reference. So let's say I want to make a change to my save case function to maybe add another column that this is patching. Maybe there's an assigned column and I want to put the current user's email address in that column. We can simply add a new row and enter the user's email there. So now wherever this function is being called, I don't have to go and update those individual save buttons. I can just update it here in this one place, and everywhere is now using that. Now we'll go back to using this for, the individual case of this form on the screen. And another thing we can consolidate is our reset functions. So in this case, all of our buttons, our save and our 2 cancel buttons, are using the same reset functions. After the action occurs, we're resetting those controls. We can take these reset functions and place them into our formulas. Here we can create a new function called fn reset case form. And we don't really need any inputs for this, and the output will be void. We'll paste in all of our reset functions and close our formula. Now in each of our buttons, we can replace these reset functions with our simple reset case form. Now, why would we do something like that? Well, in addition to standardizing the code into one place, we're also allowing for a very easy way to add new fields in the future. If there's a new field that gets added, we'll just add a second case status here, for example. Instead of adding this one control to the reset function of all 3 buttons, we can instead just go to our formula and add the additional reset there. Now in this one place, we've updated all 3 buttons. And now there's 2 final formulas inside of our buttons. One to set our selected case back to a blank value, and then one to hide our overlay. It would make sense for these to be put into the reset case form function, but I'm going to create another function just to show another example after we do this. So we'll copy both of our variables, and we'll create a function called fn hide case form. Let's go ahead and switch out our set functions in our buttons to that new formula. So as you can see, we've consolidated so much code and made the code of our buttons much simpler. By doing this, we're isolating the actual actions into the controller part of our formulas. Now, the great thing about this is we can actually chain these events. So let's say that on our save button, whenever we save the case, we also want to reset the form and then hide the form. We can chain these user-defined formulas within each other. So in the save case function, for example, we can also trigger our reset case form. And then after that, we can trigger our hide case form. If we go back to our save button, we no longer need these 2 in this button because we know when our case is saved, it's also going to trigger those other 2 functions. Again, this is all decentralizing this logic out of the button. So let's go ahead and save this. And we can confirm that that worked. One other thing to add is that since our logic is all centralized here, we can also add validation to each of our formulas. So in this case with our patch function, let's just say we wanted to check to make sure our description is not blank. If it is, we can notify that our description is missing. Now, without making any changes to our save button, we can go ahead and remove our description and try saving. And we can see that our description is missing. This is a very rudimentary example, but it's really just to prompt you to think about where you can reuse your code and how you can structure it to separate your user interface from your actions from your data. In a previous video looking at magic links inside of Power Apps, you could see some of the structure behind the checks that were done to make sure the magic link was accessible by the user that was trying to access it. You could build in those same sorts of validations just as regular formulas, and then reference those inside of your controller. We can even go one step further back and go to our gallery where we're setting the selected case, as well as showing the overlay. We could copy this formula, go over to the controller section of our formulas, and we could create a new formula for fn select case. Here we'll paste in our formula. And instead of this item, let's create an input parameter for the ID. And we'll perform a lookup function to our SharePoint list where the ID is equal to that input parameter. And we'll return this record. This could be helpful for so many different reasons, but a couple of examples would include another screen that needs to select a case and then open that case on the other screen. So we might call our select case function, and we'll just put in a number as the ID, and then we would navigate to that screen. So now from one place, I can reference that button, it navigates to the screen, and opens the appropriate record. Likewise, in our gallery, we no longer need this code. We can instead reference our select case function and input this item.id, and there again, we've centralized our code to the formulas. This might even be helpful for something like deep linking, where on start you would check if there's information in a parameter, and if so, you would call that function and pass in the value from that parameter. And of course, in the case of a deep link, you would set your start screen as the appropriate screen. So again, we have three things that are all calling that same function, and any changes we have to make to that function can all be done in one spot rather than changing each individual formula. Just to talk about the model for a moment, we can also use our formulas for standardizing our collections as well as our galleries. If we had a formula like fn get cases, we could centralize a clear collect function to get our collection of records. Anywhere we need to refresh this collection, we can instead reference our user-defined function. On top of this, we can use the input parameters in user-defined functions to dynamically filter our data sources. So in this case, if we had a filter function for our employee case log, and we wanted to filter by the case status equaling some sort of input variable. So we'll just call this scope status, and you can see we get an error right now, but that's because we have to add the input parameter over on the left-hand side. So we'll call that scope status, and we'll set the type of that as text. Wherever we call this function, we'll need to input the status that we want to retrieve. And this can help us to dynamically reuse the same function, but slightly modify it depending on the use case. If I wanted to filter by open cases, I could put in open, or if I wanted to filter by closed or pending, I could put those in, and it'll return that result, all while still calling the same get cases function. This same thing works with named formulas as well. When there are changes to your model, you can then call these refresh or get functions from your formulas up in your controller. So say after our patch function, we then want to get the items from our collection again, we could call that get cases function. We'll save a record, and then we can see that that collection was created. So again, if I had to sum this up, I would say there are 3 steps you can take. You can create a dedicated model section of your formulas, which, while we didn't really focus on that in this video, is just as important as the controller aspect. Second, you can add a controller section to your formulas that really manage the logic and the navigation throughout your app. And this way, the third factor is that you can keep your view as simple as possible. Your screens can have minimal code and minimal logic, and that pushes most of your troubleshooting and your issues over to your controller so that you only have one place that you have to go to in order to troubleshoot. Thinking this way isn't just about writing code and complicating things, it's about designing a system. And by applying the MVC design principles to Power Apps, you're building a foundation that's very scalable and maintainable in the future. If you found this video helpful, give it a like and subscribe for future videos like this one. Let me know in the comments below if you think you'll use the MVC structure in your own development. I hope you enjoyed and have a great day.